So hello everyone, this is lecture 36 for the mathematical physics. In the last lecture we discussed about the CR equations and the questions based on that, and we did up to here means we were trying to find the another means u and v by using only one, means if u is given you can find v, and if v is given you can find u, and everything like that. Okay, now we will discuss one more method which is derived from the CR equations actually, but it's a little bit easy and comfortable. So it's called the Milner-Thomson method. What happens in this method is, if u is given, then you can directly find the fz. Means you don't need to find the v first, then write the u plus iota v. You can directly find the fz through u. So how you can do that? If u is given, then you will assume there will be two functions, phi1 and phi2. These will be ux and uy. So what ux denotes here? The partial derivative of u with respect to x and the partial derivative of u with respect to y. So this is our phi2, this is our phi1. Then fz will be phi1. You will place in every place of x you will write z, and at y you will write 0. Then integrate, and again minus iota phi z z0 dz, and solving this will give you fz. So that's how you can find directly fz from u. And again you can find fz from v also. If v is given, then you will assume two functions, psi1 and psi2. So psi1 xy will be vy. You know what is this vy? Partial derivative of v with respect to y, and v with respect to x. So again fz will be psi1 z0. In place of x you will write z, and in place of y you will write 0. And same here, then solving this will give you fz. So this is very comfortable and easy method. Let's see how we implement this method using an example. If u is equal to 3x square minus 3y square is real part of the analytic function. So u is given, we need to find the analytic function fz. So what we will find? We will find these phi1 and phi2, and we derivate with respect to x and with respect to y. So ux will be 6x, this will give you 0, so 6x, and then uy will be minus 6y. So you have ux, you have uy. So now what you need to do, phi1 z0 and phi2 z0. So phi1 z0 will give you 6z, and phi2 z0 will give you only 0 because there is no x here. So 6 0 0. So you will write it in this form. This is phi1, this is phi2, and this. So we use the direct formula. Now this will give you z square by 2, so it will give you 3z square, and this is 0. So see, this is our fz. You find it the fz in a single equation. So how you can verify this? So z square can be written as if z is x plus iota y, then you can write it in this form. So from here you can see u is this and v is this. So u is again came out to be this same. And if you try to find the v, as we discussed earlier using the CR equation, you will find v as same. So now here you don't need to find the v, you can directly find the fz, and using that you can get u and v again. Okay, so this is a very much easy. Okay, so remember this method. So you can verify this also by taking this v, and now using helping v, find the fz again. You will get the same value, because here you need to find the psi1 and psi2. So vy will give you 6x and vx will give you 6y. Now again psi1 z0 will give you 6z, and psi2 z0 will give you 0. This will give you z square by 2, so again 3z square. So fz will be same whether you are finding with help of v or u. You will get the same vz fz. Okay, so we verified this method. Let's see another example. So if u is given, x cube minus 3xy square, so phi1 will be ux, it will give you 3x square minus 3y square, and phi2 will be uy, so it will give you 0, and here you will get minus 6xy. So you will write phi1 z0 will give you 3z square, and here phi2 z0 will give you 0 multiply z will give you 0 again. So you will get 3z square, and integrating 3z square you will get z cube. So fz will be z cube. So again you can verify by finding v that you will get the same fz again using this v. So this is very easy method. Now what we will see that we already see that if there is a equation given in Cartesian coordinates, then you can check if that equation or that function, complex function, is analytic or not using CR equations. But what if the equation is given in the, or the function is given in the polar form, means in terms of r and theta? Then we need to find the CR equations in polar form also, so that we can use directly them and check whether if function is analytic or not. So let's see the CR equation in the polar form. First we need to derive them. So let's see the derivation. So from here we know that if x plus iota y is a complex number, then we can write x as r cos theta and y as r sin theta, and r is nothing but modulus of z. And these are the CR equations in the Cartesian coordinates. Ux equal to Vy and Uy equal to minus Vx. So remember these equations. X is equal to this, y equal to this. Now see, now we have u and v are in the function of r and theta in the polar coordinates. So let's find a relation between these Cartesian coordinates and the polar coordinates. So you need to find the derivative of u with respect to x, partial derivative. So you need to do the chain rule. If you have multiple variables, then what will the chain rule? So ux will be ur rx plus u theta theta x. Remember this rule. If u is the function of r and theta, and you need to find a derivative with respect to third variable, so it will be ur first because of the dependent variable. So ux will be ur rx, then u theta theta x, where u is the function of r and theta. So remember this formula. We will apply this formula here. So ux will be del u by del r by del x plus del u by del theta by del x. This is just as same as this. And here r is what? R is this under root x square plus y square, because this coordinate is x plus iota y. So r is modulus of z. So this is this. And tan theta equal to y upon x. So theta will be tan inverse y over x. So these are the things we know already. Okay. Now to find this relation ux in the form of polar coordinates, we need to find the value of this rx and the theta x, so that we can remove them. So we know r, we know theta. So let's find rx and theta x from here. So rx will be differentiation of r with respect to x. It will give you this value. This 1 upon 2 root and 2x, this will give you the derivative. So 2 will cancel out, and this under root x square plus y square is nothing but mod, means r, mod of z, that is r. So x by r. Now x by r you can see here, x by r, this is nothing but cos theta. So you change the rx in the form of polar coordinates, that is cos theta. Now we need to find the theta x. So theta is given this. So tan inverse x, derivative of tan inverse x is 1 upon 1 plus x square. So theta x will give you 1 upon 1 plus y square over x square. And then y over x will give you minus y over x square. So that will be the derivative of theta with respect to x. Now from here you can see x square plus y square, x square will cancel out. So x square plus y square is nothing but modulus z square. So that will give you r square. In the numerator you will have minus y. So from here you can see y over r is nothing but, y over r is sin theta. So you will get minus sin theta over r. So you have now rx in terms of theta and theta x in terms of theta and r. So you can substitute them in this equation and you can find the ux. So ux will be ur cos theta minus du theta sin theta by r. So you already find it ux. Now you can find uy also. So why we are finding these? Because we know the CR equations in this form. So we need to find all these four to convert them in the polar form. So uy will be, again using chain rule, u is the function of r and theta. So it will be ur ry plus u theta theta y. So again you will use the same method. You will differentiate this with respect to y and this with respect to y. So you will get these as your answers. Ry will be y over r, that is sin theta. Theta y will be x over r square, that is cos theta by r. So you can check them, these are right. So just substitute in this equation and you will get this equation, uy equal to this, ur sin theta plus u theta cos theta by r. So now you have ux, you have uy. Again for vx you will use the chain rule, vr rx plus v theta theta x. You know rx theta x from here. Substitute here and you will get this value, vr cos theta minus v theta sin theta by r. Now Vy is again chain rule, Vr Ry plus V theta, theta y. So using theta y and Ry, from here you can get this equation. Now you have all four equations for Ux, Uy, Vx, Vy. Now we will use these equations which we already know, the CR equations. Ux equal to Vy. So first we will put Ux equal to this Vy. Okay. Then we will use the second equation, Uy equal to minus x. So Uy this equal to means Uy plus Vx equal to 0. So Uy plus Vx is this equal to 0. So we have taken the sum and equal to 0. So you can take this whole term to this side, negative of this equal to 0. You will get these two equations. So first you will do that multiply this whole equation with cos theta and second equation with sin theta and add them. When you will add them, then you will get ur cos square theta, ur sin square theta will give you ur only, and many terms will cancel out. So in the last you will get this equation, ur minus v theta by r. This is just a simple addition. You can check them, the terms will be cancel out. So you will get this equation, ur minus v theta by r equal to 0. From here you can check that ur equal to v theta by r. So this is our first CR equation in polar form. Okay. To find the second equation, what we did, multiply with sin theta in this equation and cos theta in this equation and subtract them. Okay, subtract this equation from this. So then you will get sin square theta here, cos square theta here. This will be minus this side. When you subtract them, you will get VR only and some kind of this form. So after solving that, means only after subtracting, you will get this equation, minus u theta by r minus Vr equal to 0. From here you can check that u theta will be minus rVr. So this is your second CR equation in polar form. So these are our CR equation and Cartesian coordinate, that is ux equal to Vy, uy equal to minus Vx, and these are equation in the polar coordinates, ur equal to V theta by r, u theta equal to minus rVr. So remember these equations too, very important. They will save your time. So let's take an example. If f is given r6 cos 6 theta plus I sin 6 theta. So this is given in polar form and we need to check if this function is analytic or not. So we will use these equations. We will find ur. First, what will be u? r6 cos 6 theta will be u and v will be r6 sin 6 theta. Now you will check ur. So ur will be 6r5 cos 6 theta and you will check v theta. So v theta will be sin 6 theta will give you cos 6 theta and 6. So you will check that ur will be equal to and divide by r. So ur will came out to be v theta by r. So it satisfies the first equation. Then check for the find derivative with respect to theta and substitute in this equation using these. You will get this that both came out to be equal, minus rVr equal to this and this is equal to u theta. Okay, these both came out to be same. So we can say that this function is analytic and you can see that this is nothing but r cos, means using de Moivre's formula you can put this 6 into the power. So it will be r cos theta plus I sin theta to the power 6. So that is z to the power 6, and we know that these kind of functions are always analytic because these are in the polynomial form. So that's it. Means not the lecture is ended. Means here we ended with the CR equations. Now we will study some complex functions. Means some natural real functions like trigonometric and the exponential functions in the complex domain. So how they change and how they vary. Okay. So first we will start with exponential function. So if we define this function in the complex domain, then it is nothing but extension of exponential x in the complex plane. Okay. Real x means complex expansion of real x, exponential x. So by definition we write exponential z as this, exponential x cos y plus iota sin y. So this is the definition of exponential z in the complex plane. Okay. So exponential z is nothing but natural expansion of exponential x in the complex domain. So remember this definition. Now let's check what this definition gives us or how it actually is. So from this, if we see that exponential, let's find the modulus of exponential z. So it will give you take the mod of this and mod of this. So mod of this will give you 1, cos square y plus sin square y will give you 1. So mod of exponential z is nothing but exponential x, and this is never gonna be 0 because this is exponential x. So at any value it will have some real value, or so it will not be 0 for any z. So remember this first property, and the mod of exponential z is exponential x. Now see, if we put y equal to 0 and there is x and y equal to 0, so you will get again exponential z as exponential x. So this proves that this is the expansion of natural expansion of exponential x, because when it is real then it will again give you exponential x. Y equal to 0 will give you 1 here and 0 here, so it is again exponential x. See now second property is exponential z is an entire function, means this function is analytic at all z. Okay, as we already know about exponential x, that is also analytic for all values, means if you find the derivative of e to the power z will give you ez again, as for ex you will get ex again. So these are the correlations. Now let's say if fz is u plus iota v, okay, then we already proved this, that df by dz is ux plus iota vx, means it is independent of directions we are taking. Okay, you can check from here. Exponential x cos y will be u, and ux will give you ax cos y again, and exponential x sin y, and then vx will give you again exponential x sin y. So this is again exponential z. So that's how we prove this. Ez dash will be ez. Now you can write this also in this form. Exponential z1 exponential z2 can be written as exponential z1 plus z2. Let's say z1 is x and z2 is iota y, then exponential x exponential iota y can be written as exponential z. Okay, from here if this is this, then we can see that we can compare this equation with this. Now if z is x plus iota y, then exponential iota y will be equal to this. So from here this definition came out. Okay, till now we were discussing this form, this polar form, but what we will see now, exponential iota y, after comparing we will get this value for exponential iota y, cos y plus iota sin y, and this is called Euler's formula. Okay, so actually till now we were using this polar form, z equal to r cos theta plus I sin theta. Now we know that this can be written in this form, so we write it z equal to r exponential I theta. So from here we are starting to use this kind of form. Okay, so remember this. Now it is very easy to do many of the things, like we can calculate exponential iota pi by 2. So you can use means r is 1 directly, so cos 90 will be 0 and it will be iota. So same, you can just put in the formula, you can find the values of these, they will come out to be this, and see that magnitude of exponential iota y is always 1, because we can see directly r is 1, and this is also nothing but this, and under root cos square y plus sin square y is 1, that's why this is 1. So this is the equation of a circle. So means this is a periodic, means this component is periodic. I will tell you more about this in this lecture itself. So you will see that this component is periodic in the exponential z, means exponential x is a real function and non-periodic, but when we come into the complex plane, exponential z becomes periodic, where only the period comes in the y terms. So mod of exponential z is never be 0 because it is exponential x, and for all z it cannot be 0. So there is this last property we will study. If z can be written as r cos theta plus I sin theta, and exponential z is exponential x cos y plus I sin y, then we can see that r is nothing but exponential x, because r is mod z, and from here we can compare that argument of this exponential z is nothing but y, and we know that argument is have different values and it can repeat itself. So argument of exponential z will be y plus minus 2 n pi. So after 2n pi it will repeat itself, where n goes from 0, 1, 2. Okay, so that's how we can say that this exponential z is periodic in y. So period will be 2 pi iota. So how we can prove this? So what is the meaning of period? If x plus p becomes fx again after p values, then we will call that p as its period. Okay, so let's check the period for this. So if fz equal to exponential z, then put fz plus 2 pi iota. So it will give you exponential z plus 2 pi iota. So write z as x plus iota y. So it will give you exponential x plus iota y plus 2y. Now write this exponential x, and exponential I theta will give you cos y plus 2y, sin y plus 2y. So they will be again sin y and cos y. So that's how we prove that this is equal to Ez again. So 2 pi is the principal argument, okay, principal value, and 2n pi is the argument of exponential z. So what we conclude from this? We conclude from this that this exponential z function is limited to this region, means this is the domain, x to the infinite and y to the iota pi and minus iota pi, because we know y is argument, so it will limit in the minus pi and the pi, because whatever value is giving from these values, it will repeat itself after this region, means these values will come again and again and again to the denominator and the numerator, means both sides they will come again and again. So this is the fundamental reason exponential z, means whatever value we were getting for these, any complex number will be lying in this region, will give us the same value in again region we were getting. Okay, so this is the fundamental reason of exponential z. Okay, and y is greater than minus pi and less than equal to pi, because y is argument, and we already talked about the arguments that they lie between minus pi and pi, and this y-axis form the circle, and x-axis is a normal axis. So remember this is the fundamental reason, and it will repeat itself after this value, after this value. So exponential z values will be getting, means all exponential z values we can get from this reason itself. Now let's check some things, some examples. So question can be asked like this: if solve this value, so you can write it directly. It's exponential 1.4 and exponential minus 0.6 iota can be written as this: cos theta plus I sin minus theta, so will give you minus this. So you can use calculator and you can find directly. This is in radians, so this will be your answer. Now it can be given like this: exponential z is 3 plus 4 iota. We need to find z. So exponential z is nothing but exponential x cos y plus I sin y. So we will compare the things, means the mod of this will be mod of this. So mod of this is exponential x equal to exponential x. Mod of Ez will be exponential x, so it will be equal to under root this 9 plus 16 25 will give you 5. From here take the log, so it will give you x equal to log 5. So you have the x now. Now using this exponential x cos y equal to 3 or exponential x sin y equal to 4, using any one of them and put it exponential x as 5, so you can find the value of y. So that will be 0.927. Then you can add plus minus 2 and pi because it will remain same in that period. So z will be x plus iota y plus minus 2 and pi. So that's it for today. In the next lecture we will discuss about the trigonometric function and the hyperbolic functions. Okay, thank you everyone.